here we have an experiment to turn a very plentiful oversupply of hardwood in the US called tulip wood. As a species, it sits between softwood and hardwood, really, but it's used by the construction industry as almost like a sacrificial material. They not only cut through it in the forest to get to the good stuff, they also take this weed and treat it as skirting boards due to be painted. Criminal! And I wanted very much to transform its debased personality or the perceived personality of it into, through a kind of Midas process of engineered timber, make it into a special product. And we took various tulip woods from the US, donated for the Design Festival in London, and made cross-laminated hardwood, which was a fantastic process to do together with Arup in order to analyze the performance characteristics of it, and with Nussli in Switzerland to develop very beautiful jointing techniques, which of course they're very advanced in already. And even things like this mitring joint, it looks like it's a way of, if you like, fingering in order to make strong, but it's entirely in order to make the glue surface bigger, the line of the glue going longer. And we made the stair which is entitled Endless Stair, as an homage to Escher. It is not about having no end, it is about endless configurations for pre-manufactured modular construction. So that these flights, we made 13 of these flights, in turn could be dismantled into each tread and reconfigured in many different ways. It was assembled first at Tate Modern in London, where we used 13 flights to demonstrate this particular configuration. I was quite happy with it, but I was a bit cross with Arabs because they insisted on having columns in it, and the whole point of this idea was to be able to have a column-free stair structure. But you know, obviously I took advice and but had revenge, because in Milan we got it as a pure cantilevered structure, and I think much sweeter, using only 9 of the 13. If you're interested in this particular timber, it has been the research has been extremely well documented. I have a book here which you can check out, and if you're interested, they'll send you one. It's basically a project that, because there was a lot of scrutiny on it, and because of its experimental nature, the research was not just about the structural testing. And yes, it's lighter and stronger than conventional CLT, and it outperforms it in things like shear, particularly rolling shear, and therefore the ability to cantilever, and things like deflections are much less. It's much stronger. But the research documents the life cycle analysis, which doesn't just look at the carbon, which incidentally is 14.5 tons absorbed in that stair alone. It's about the impact on manufacture, the energy of the factory, the transport, the glues. All of it is extremely carefully analysed and set out in that document.